Hi, this is a follow-up video to the decade resistance project that I done a little while ago. What actually happened with these is I was looking for one of these and I couldn't find anything that was cheap and easy to get, and I just thought, you know what, I'll make some. And the reason why I decided to do that, I did mention this in the last video, is because I wanted to get some manufactured and go through that process, go through the design process and go through the manufacturing process and get them made by machine. So the net result was I had to make quite a lot of these, in fact 200. I made the 200 of them first of all. And what I figured is if I found it useful, I'm sure there will be other people who would also find it useful, and that's how I justified it, and I spent some money and just got them made. My plan was to stick them in a box in the garage, and you know, maybe people would buy them over a while, and they'd be there. In reality, what happens is the whole lot sold in about 10 days. So go figure. I wasn't expecting that, but clearly. A lot of people that watch my blog and have subscribed to my blog were people that have bought that, and I am very grateful for everyone supporting the project. That's really good. It you know, it gave me some good positive feedback, and I'm only glad that I was able to make something that that was actually useful to other people. So I just wanted to say thank you for actually supporting the project and buying them. The feedback I got on these resistor boards was really great. I mean, I wasn't expecting nothing like the level of interest that there was in these boards, and you know, I don't know if that's because you guys all really found it useful, really thought it was useful, or maybe you just felt sorry for me. I don't know, but whatever. I'm actually very grateful, and there was some really good feedback, and you know, just obvious stuff often that I missed. So I was going to cover a couple of those points because the second batch of these resistor boards that I had made and the subsequent capacitor board that I'd made, I'd applied a lot of the points of feedback to the footprint. So quick update on that. The first thing is the first thing someone pointed out that actually if you place this on your bench while there's bits of solder, bits of cut component leads and so on, you know, you can short it out, and that's not really great. And someone suggested that if either if there was space on each corner to stick, you know, there's kind of rubber feet to, or someone else will suggest if there was just mounting holes in the four corners, which I suppose is a bit of a sin, the fact that I didn't even consider that when I'd done the first design, which is absolutely right. So I did make that change. You can see on this board here, I've got 4 mounting holes in the corner, and just so you know, the capacitor decade board and the resistor decade board are exactly the same form factor. So that 3D case that someone designed, they both will fit. But with those 4 mounting holes, what you can do then, I've just here as an example, I've used M3 screws and nylon hex spacers and screwed those on. So you know, a nice little four-legged stand. Just to keep it off the bench, which is quite nice. So I've made that change. The second thing I'd done to it was exposed the solder mask or receded the solder mask on these holes designed for the 4mm jack. Previously the solder mask was covering that completely. Now I've brought those back just to expose the metal, because when on the back, when that nut goes on and the washer, it just makes better electrical contact. Not that it matters, because actually on the even on the original one, you just take the tabs coming from that washer and just solder them onto here. Anyway, I've done that because it's a little bit neater. Another really good suggestion someone had made, and actually it was a mod that they'd done after they'd received the resistor, was I've had the assembly house put a solder bridge across the 9 position on each of the 7 decades. Now, why do that? Well, it doesn't impact the operation of the resistance at all when the jumpers are in place. So when the jumpers are all in, it works just as it does before. What it does do though is when you remove a jumper from a decade, in the original design without that solder bridge, the resistance will now go over open circuit. That might be perfectly okay, but your circuit, you know, particularly if you're working on high-powered circuits or circuits that might be sensitive to, you know, substantial changes, especially if you're down in the low values and suddenly it goes open circuit, your circuit might not tolerate that. And so a simple modification there means that whenever you remove a jumper off a decade, instead of it going open circuit, what happens is the resistance raises just to the highest value on that decade and no higher. and that's, you know, safer. So my view was, after someone suggested that, and it's very obvious, so for that suggestion, thanks very much, I thought, you know, that's very sensible, and I can think of more use cases where that would be preferred than not. So when I had this second batch assembled, I actually asked them to put their solder bridge on there. And the reason why I didn't design it into the board is because there may well be real use cases where actually that's not appropriate. So if that's the case and you buy one of these, you can simply solder sucker and just remove those bridges, and you're back to the original design. So that was a sensible thing there. Other than that, everything is as it was previously. Buying them. Anyway, one of the there was lots of comments and lots of really positive feedback, and one of the things that really came out, or you know, quite a common theme, was what about a decade capacitance? And you know, I gave that some thought, and after a little while, I came up with this. Now, of course, it's probably about what you'd expect. What it is, it's a 5-decade programmable capacitance, or settable capacitance, whichever way you want to put it. Not everyone liked the word programmable. I'm going to use it though. So 5-decade programmable capacitance from 100 picofarads right up to 9.9999 microfarads, rated at 100 volts. Quite a useful range. The board has a residual capacitance with no jumpers on of about 25 PF. So for all you RF guys who are probably rolling on the floor laughing now, this is not for you, okay? Not for your RF circuits at least. But what it is useful for is where you're working on analog circuitry, or you know, power supply circuitry, where you're looking at noise and you know, differing capacitors depending on the surrounding inductance and resistance can have really dramatic impacts, and not always easy to work out using, you know, simulation tools like SPICE. So you know, certainly for me, I find it quite easy to actually plug something like this into the part of the circuit I'm working on and trim around and have a look and look at the response on the scope. In my power supply project, I found this particularly interesting, particularly useful for trimming out the compensation networks around all the feedback circuitry. You would have seen in I think in part 14 of my power supply project, I've done a fair bit of that, and I didn't have one of these. What I had instead was a whole bunch of bags of small disc ceramic capacitors, all spread across my bench, and I was picking values based on the responses and looking at the results on the scope. I've since done some more tuning on that project around the higher voltage implementation. There'll be a video following soon, so I haven't forgotten about the power supply project. For those of you that are wondering, because I know there's quite a lot of people that are keen, so I just thought I'd make that point. And I have used this, and actually it's really great for that. It's you know, you can trim values. You know, if you ask the question, what if I put 10 times the value in here, or what if I reduce it by 10, or yeah, I'm getting pretty close, but I need to trim it out. And you know, certainly when you're using this in combination with a programmable resistor, you can really tune those circuits. And if you're learning, like I am, you can see on the scope the the effects of those different values of capacitance. So now using this, you know, so I guess it's the one slightly disappointing thing, and I'll tell you about the rationale afterwards. But I did look at, you know, switches. You don't really find decade switches that will progressively parallel each pole as you rotate the switches. So you know, to get a parallel, and because obviously to produce a decade, you actually need to put capacitors for capacitance. Unlike resistance, which is serial connected, they're all just put in series. With capacitors, you have to put them in parallel and build the capacitance value. And the problem with that is, how do you do that? So when I looked around at what other people done, you do find often you'll find decade, well, they call them decade capacitance boxes, but they're not really decade capacitance boxes. You'll have a set of preferred values, you know, 1.1N, 2N2, 3N3, 4N7, and so on, and then you'll have the next decade up again. And what you can basically do is you can dial up one capacitance value on each decade, and they get paralleled, and you get the resultant value. So you won't be able to dial up precise values, just some approximations, and depending on the design, that can be perfectly acceptable. I didn't want to go down that route, one, because and if I would have went down that route, actually I could have used the potentially could have used the same format as the resistance. What I decided to do instead is use this format, and if you look closely, you'll see that each of the 5 decades actually has 3 columns of pins. And so what happens here is the jumper, if I just show you this in use, or show you a populated one of these, a jumper can either be to the left or to the right, so on the 0 or the 1 position. And each time you move it from 0 to 1, it adds its respective capacitance into the chain. So the numbers down here don't really mean, you know, where are we on here, 100 NF. So it doesn't mean 100 NF, 200 NF, 300 NF. What that means is each one of those positions has 100 NF on it. So if you want, where are we, in this case, if you want 5 NF, you just put any 5 jumpers across to the right hand side, and you know, that means that it's a true decade capacitance, which is not the case for a lot of the ones that I've seen around, which have just made up of some, you know, series of preferred values. Now I will freely admit that actually it's a little bit awkward to use, because it's, you know, if you've got big fingers like I have, you know, you're fumbling around a bit with those jumpers, so it's not perfect. And what I found when I was using it, my, you know, sort of basic experiments using it, I started off trying to use my fingers, and it was very awkward. And in the end, I just had a small pair of I'm not sure I've got them around here, smaller than these actually, small pair of snipe nose pliers, and I was just lifting each jumper off and moving it across, which made it very, very easy. Now the rationale, why did I go down that design route? What I concluded was that, you know, again, cost. I was trying to keep the form factor the same. I was trying to keep the, you know, the design identity, if you like, the same, so it was familiar and kind of fit. The form factor was the same, so it fits into the same 3D case if you printed one of those, or you know, and the rationale is you don't really need this often. This is not a tool that you're going to use every day. This is not something that would annoy you. I mean, if I had to use that every day, honestly, it will bug the shit out of me, because it is just too, you know, it's fiddly. But in the rare occasions when you're going to spend that 2 hours or that hour and trim out that circuit and try and fine tune that feedback or that compensation network, I can't argue, you know, for the cost of this. And the acid test for me is, if I'd seen this for sale and I wasn't inclined to make my own and get some made, you know, would I buy that and have it around my bench and just use it, you know, for that odd occasion when I need it? And the answer is, you bet I would. Yeah, absolutely. It's just too useful, and the time saving is great. Also, with capacitors, they're quite a lot more expensive than resistors, as I'm sure you know, because of the materials and the metals that are in them. And I was treating capacitors exactly the same. In fact, I bought large batches of bags of different varying capacitance values. And I specifically pull them out, spread them across the desk when I'm doing that kind of stuff. And what happens in reality is you take them out of the bags, and they're very small. My eyes aren't, you know, perfect, so sometimes I can't be bothered to figure out what values they are and put them back. So it's actually safer for me to just throw them away. So often I do. And again, you know, having this just makes that a bit better. Anyway, I'm not going to sit here and try and sell it to you. You can hopefully you can see what that is. I'm sure some of you find it useful. So I have had a bunch of these made, and I'm going to stick them up on eBay and on Tindy.com. And in fact, if you are going to buy one, if you do want one and you think they're going to be useful, please use Tindy.com. It's the cost, the actual charges on the transactions are a lot lower. And also not so much that, but I've had an awful lot of trouble with the eBay system. Since I've been doing this, you know, dealing with the postage and stuff is a real pain. Anyway, I'm not going to go on about that and rant on about it, but that's what I'm going to do. I'm going to make them available. So to find them, I will have on the blog post that goes along with this video, and the link to that is just down here, so just below the video if you're viewing in YouTube. I will have the blog post with details on what to search for and what to look for. But if you go to Tindy.com, and I'll put a a label up here so you can see the exact spelling if you're not familiar with the site. It's actually quite a neat site. Go there and there's lots of makers selling stuff, bits and pieces like this. So if you just go there there or either there on the eBay and just search for Jerry Sweeney, all one word, just like my domain name, Jerry Sweeney, all one word, or jerrysweeney.com, and you'll find them there. All right, so I've got. I think that's it for now. I just want to again just say thanks very much to all those of you that have supported the project. It's been really interesting and entertaining for me. The level of engagement, it's driven some traffic to my blog, which has been really great, and I do really appreciate it. I just want to say thank you very much. And as I say, if you want these capacitor ones, they are available. No pressure though, don't feel you have to. Okay, thanks very much for watching, and I'll catch you next time.